Hi everyone. So today we're going to be looking at derivatives of simple functions. So this is obviously for maths methods for Unit 3 and more specifically for Area of Study 3, which is calculus. So the learning intentions today are that by the end of this video, you should be able to differentiate or derive simple mathematical functions, including linear equations, quadratics, cubics, quartics, and so on. You should be able to determine the slope of a tangent line, and you should also be able to find the coordinates of a maximum, minimum, or turning point. So just a refresher, first of all, last year, we used something called first principles, which is this. So you might recognize this. It's a bit of a difficult and clunky way to differentiate a function. So you'd be glad to hear that we don't need to differentiate things this way this year. There is a much easier and much quicker way to do it. So this way starts off the same. We start with the exact same function that we had before. As you can see, we're using f of x equals x squared, or in this case, y equals x squared, because f of x and y are the same thing. And first of all, to differentiate or derive y, the function is first multiplied by the power, and then the power is decreased by 1. So, as you can see here, the x squared has been multiplied by the 2 from up here, and then the 2 has been decreased by 1, resulting in the same answer as we had previously using the first principles, which is dy dx equals 2x. Now, if you didn't get that, we'll go through another example here, and hopefully it'll make a little bit more sense. So this time we'll use a different function. This one will be f of x equals 3x cubed plus 5x squared minus 2x plus 4. So once again, we do the exact same thing. We multiply each individual term by its power and then decrease that power by 1. So this is one term, this is another term, this is the third term, and this is a fourth term. So when we go through it, the first term will be multiplied by the 3, as we can see here, and then the 3 will be decreased by 1 power, okay? Then this 5x squared will be multiplied by this 2, and then the 2 will be decreased, as you can see here. Now the third term, the exact same thing happened. So since this is x to the power of 1, technically, the whole term is multiplied by 1, and then the power is decreased, but since this results in x to the power of 0, the x just becomes 1, as you'll see later. And this final term, since there's no x, it actually just becomes 0 when we derive it, okay? So after we multiply everything out, this is what we're left with. F dash x equals 9x squared plus 10x minus 2. So as we can see, 9x squared is because with this first term, we've done 3 times 3, which equals 9. And then 3 minus 1 is 2 for the power. And then for the second term, 2 times 5 equals 10. And then with the powers, 2 minus 1 leaves x to the power of 1. And then with this third term, 1 times 2 is 2. And then since x is to the power of 0, it just becomes 1, okay? And as I said, this fourth term just disappears. So this is what we're left with. And this is the exact same for any function like this. So it doesn't matter what power is on any of these terms. It works the exact same way, okay? So now you might be wondering, why do we differentiate functions? Why do we want to do this? So the first derivative of a function tells us the instantaneous rate of change of a function at a certain point. So in other words, it tells you the slope of the tangent line at a certain point for a function, okay? So now we'll look at an example. So if we're looking back at that first equation that we used, the y equals x squared, as we already know, dy dx equals 2x. We calculated that before, okay? Now, if we were asked to find what the instantaneous rate of change is at the point where x equals 3, all we need to do is sub in x equals 3 into dy dx. So x equals 3, so now dy dx equals 2 times 3 because the x has become 3, which obviously equals dy dx equals 6. Okay, so this means that at the point where x equals 3, the slope of the tangent of y equals x squared is equal to 6. And to show this graphically, we have the function, the graph of y equals x squared, right? And at the point where x equals 3, the point is 3, 9, okay? That's pretty easy to work out. We can all work that out. So this black line is the tangent to the graph at that point, 3, 9, okay? And what we've calculated is the slope of this tangent is 6 when x equals 3, okay? Now, there are further uses for the first derivative, and a key use is to actually determine where a maximum, minimum, or turning point of a graph may be. So this is calculated simply by making the derivative equal to 0 and then solving for the x value at that point. So once the x value has been found, it can be subbed back into the original equation to solve for y, and then you'll have the coordinates of that point that you've just found, which is either a maximum, a minimum, or a turning point, depending on what type of function you're deriving, okay? So we'll use this function as an example. So y equals x squared minus 4x. So first, we have to calculate the derivative, which will be dy dx equals 2x minus 4. So as before, we've done the exact same thing. We've multiplied this x squared by 2, and then the 2 has decreased by 1 and has just become power of 1, okay? So 2x. And then the 4x has had the exact same thing happen as well. So the imaginary power of 1 here has been multiplied, has multiplied the function, and then since x has gone to the power of 0, it just becomes 1, okay? So it results in dy dx equals 2x minus 4. So now, as said previously, to find a turning point, we have to set the derivative to 0. So that means we make dy dx equal 0. So therefore, 0 equals 2x minus 4, since we've made this 0, okay? So now we can solve for x to find the x coordinate of the point that we're looking for. So to solve for x, we rearrange this to give 2x equals 4, and then obviously that gives you x equals 2. So since we've now found the x coordinate of the minimum of the graph, we are now able to find the y coordinate. So to find the y coordinate, we sub x equals 2 back into the initial equation. So our initial equation was y equals x squared minus 4x. So once we sub x equals 2 into it, and then we solve, we're left with y equals negative 4. And now we see that we've calculated the coordinate for the turning point of the graph. So the coordinate for the minimum, which is 2, negative 4. So x equals 2, y equals negative 4. And as you can see in this graph here, it is a local minimum, and we have been able to determine where that point is. So our final tips are, don't get scared off by equations that have large powers, because as shown, they behave exactly the same way. You do the exact same process for every single one. So every single basic function like this, you do the same procedure. So a future video will tackle the derivatives of circular functions, logarithms, and exponentials, because they behave a little bit differently when you derive them. Thank you, and I'll see you in the next video.